give her the answers, I will just post them at the beginning. Okay, so let me put these answers up here so she can check. Answers to yesterday. Slide it up. She can pause it if she needs to. Those and those. Okay. All right. Two birds with one stone. Okay, so guess what we're talking about today? Take a wild guess. Triangles, yes. So we're talking about, more specifically, trigonometric. Say that word. Trigonometric. Guess what we shorten it to? Trig. Functions and acute angles. What is an acute angle?
Less than.
Clarify. Small. Less than 90 degrees. Okay. So remember from geometry, similar triangles have the same angle measures, same shape, and their sides are proportional. The following triangles will be similar but not congruent. What does congruent mean? Yeah, identical in every way. So same angles and same side lengths. These clearly are not the same side lengths, but they would be proportionate to each other. So maybe, I don't know if this is true, but maybe this is half the size of this one. So I would have a ratio of 1 to 2, or a ratio 2 to 1. Okay? So that's what we're going to be dealing with for a while now, is similar triangles. So think of, do you remember, did you ever have a teacher maybe in elementary school that had an overhead projector? And if you roll the projector closer to the screen, what happens to the image? It gets smaller. You roll it away from the screen, it gets bigger. You didn't change the shape or the image, but it changes the proportion of it, right? So those are examples of similar shapes. So like a dilation or a shrink of a certain image. Okay, so here's a handy-dandy right triangle. Notice I do have the vertices labeled ABC, but I also have a theta right in here inside this one. Which angles are acute? Let's just use A, B, and C for our angle names for now. A and B, because they are less than 90 degrees. Which angle is right? C, meaning 90 degrees. Which angles are complementary? A and B, what does complementary mean? Adds up to 90. A and B. Do you have a hard time remembering what complementary and supplementary means? Do you get them confused? Nobody? You want a stupid little hack to help you remember? Okay. Complementary starts with a C, but complementary angles add up to 90 degrees. Supplementary angles add up to 180. 180. Cool. Okay, so complementary adds up to 90. Supplementary adds up to 180. What is angle A plus angle B plus angle C? Therefore, they are what? Supplementary. Awesome. Okay, so you probably, hopefully, fingers crossed, remember learning about sine, cosine, and tangent in geometry. Does this ring a bell? SOHCAHTOA? Anybody? Okay, it's a little mnemonic device that we use to help remember what sine, cosine, and tangent are. I'll come back to that in a minute. But in your geometry class, you only talked about those three, sine, cosine, tangent. Did you know that there are actually 6? What? There are 6. So here's your sine, cosine, tangent. But then they each have a, what do we call that? Reciprocals. They all have a reciprocal. Okay, so let's go back and review the 3 that you've used before. Okay, so here's actually how we spell sine. But 4 letters is way too many to write out, right? So we shorten it to 3. So we use sine. Okay, here's a pet peeve. I have plenty of pet peeves, don't I? The rings on the table. Okay, when you read this, it does not become sin. That does not become cos. It is still sine and cosine. So if you go to the doctor Do you call the doctor Dr? We abbreviate it to Dr, but you don't change it to Dr, do you? If you live on a street or a road, you don't live on st or erd. Like, it's an abbreviation, but we still use the full word. So that is still sine, and that is still cosine. Okay, so sine is the ratio, think fraction, of the opposite length over the hypotenuse length. Okay, go back up here. Here's my theta. Opposite theta is this side over here that actually has nothing to do with theta. It's not touching theta, it's not forming theta. That's your opposite. The hypotenuse, that's always opposite what? Hypotenuse is always found opposite the right angle. Okay, so that one's pretty easy to identify. Then the other leg of the triangle is the adjacent one. The adjacent one actually helps form the angle along with the hypotenuse. Okay, so you have opposite, adjacent, hypotenuse. Now, if I move up here to angle B, hypotenuse doesn't change. That's still a hypotenuse. But with reference to angle B, this side is now opposite, and this side is now adjacent. So the two legs, or the sides that make the 90-degree angle, they change opposite, adjacent, depending on which angle you're referring to. Hypotenuse always stays the hypotenuse. Okay, so when I talk about its opposite over hypotenuse, it's the length of the opposite side divided by the length of the hypotenuse. Okay, cosine, that's certainly too many letters to write out, so we abbreviate it to COS, still read it cosine, and that's the ratio of adjacent side divided by hypotenuse. Then we have tangent, abbreviated to TAN, is the opposite length divided by the adjacent length. Okay, so those are the three that you used in geometry. 3 new ones, and this is all, there are only 6. Cosecant. Okay, abbreviation is CSC, but we still say cosecant, and it is the reciprocal of sine. Therefore, it's the hypotenuse over the opposite length. Secant is the reciprocal of cosine. SEC is the abbreviation. It's the hypotenuse divided by adjacent. Cotangent is reciprocal of tangent. It is adjacent over hypotenuse. Are we good there? Okay, so total of 6. Let's go back to SOHCAHTOA. What does that mean? It's not a real word.
Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent.
Yeah, it's just the letters in order so you can remember. Sometimes people write it like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you like that image, that kind of reminds you of the fraction. But what we don't have is a little reminder for these. So guess what we have to do with these? Memorize them. Okay, so here's my little tip for these. Okay, there are 3 words that start with co. Cosine, cosecant, cotangent. None of those go together. So in each pair, there's one co. Sine goes with cosecant. Cosine goes with secant. Tangent goes with cotangent. So each pair has one co. Co's don't go together. Okay? So we will use them so much, it will just become second nature, though, hopefully. In a little bit, I will want you to put these on your formula sheet if you need help remembering them. Or maybe just put little abbreviations for them. Okay, next page. Evaluate all 6 trig functions, or ratios, of a 45-degree angle. Okay, so first we're going to draw a 45, 45, 90 triangle, which I have already printed here for you, and label the sides with simple values. Use one for the legs, and then determine the hypotenuse using Pythagorean theorem. Then, using all 3 lengths, evaluate sine, cosine, tangent, cosecant, secant, and cotangent. Okay, if I have a 45-degree angle in a triangle, what is the other acute angle? 45. Because those 2 angles have to add up to 90. They're complementary. And there is my right angle. Okay, so I said label the sides with simple values. We're just going to use 1 for the legs. 1 just because it's an easy value. Okay, how would I find the hypotenuse using the Pythagorean theorem? What is Pythagorean theorem? A squared plus b squared equals c squared. What are a and b? Okay, they're the legs, which are 1, and c, of course, is the hypotenuse. So I would have 1 squared plus 1 squared equals c squared. Well, that's 1 plus 1, which is 2. So what is c?
4.
What would I do to get rid of that square? Square root. So c is the square root of 2. Now, often when we take the square root of both sides of an equation, I'll say we have to do plus or minus. Let me go up here and talk about that. If I told you that x squared was 9, what is x? Maybe. Maybe. So I'd have to say, okay, take the square root, but there is a positive and a negative possibility. Because couldn't x be positive or negative 3? And when I squared it, I got 9, right? So usually when we just straight up solve an equation and take the square root of both sides, we'll have to put that plus or minus here. But this is the length of a triangle, so I'm only going to use the positive here. Okay, so my hypotenuse is square root of 2. Okay, so which angle am I looking at? Remember on the previous page I said what's opposite and adjacent depends on which angle you're using. Which angle am I using? Or the top. It doesn't matter here because they're the same. Okay, so if I say what's opposite 45, it doesn't matter which one of these you look at. You're going to get the same result here. Okay, so I'm going to just say we're looking at the top one. Okay, but again, it really doesn't matter because we're getting the same result. Okay, so go back to your ratios. If sine is opposite over hypotenuse, what is the length opposite 45? 1. What is the hypotenuse? Square root of 2. Okay, now, when you get to AP Calc, and later in this course too, I will probably say, I don't care if you leave that radical in the denominator. But in algebra, we usually simplify that. We consider a radical in the denominator not simplified. So we do this little thing called rationalize the denominator. Remember that? Yes? Maybe? I'm going to multiply by that fraction. What does that fraction equal? 1. So I'm not changing the value of it. When we multiply fractions, we go straight across. So 1 times square root of 2 is square root of 2. What is square root of 2 times square root of 2? Yeah, square root of 4, which is plain old 2. So that would be the sine. Okay, let's go ahead and do cosine. Cosine, looking back at your ratios, is adjacent over hypotenuse. What side is adjacent to this 45? Right here, another one, right? So looking at this angle that I put an arc, this is opposite, this is adjacent, this is hypotenuse. Okay, so if I want the adjacent length, that's 1. Over the hypotenuse, that's square root of 2. Isn't that the same number we had here? So when I rationalize it, what am I going to get? Square root of 2 over 2. No surprise there. Okay, tangent. That is the ratio of opposite over adjacent. Okay, well if I go back to my picture and I look at opposite length and adjacent length, they are both 1. And 1 over 1 is 1. Do you remember doing that in geometry? Oh, like so non-responsive. Thank you, Thomas. Thank you. Okay, so now let's find the reciprocals here. Reciprocal of sine is hypotenuse over opposite. Okay, I have two choices here, guys. I can flip this fraction and make it 2 over square root of 2. Guys, up here, look up here, please. But if I flip that and make it 2 over square root of 2, then I have to rationalize it. So be smart. Let's just choose this fraction and take the reciprocal of it. They're all the same, right? I just might have more reducing to do if I use that one. So if I, if I flip that fraction, take the inverse of it, the reciprocal, then that's just square root of 2. So I don't even need a calculator, do I? Okay. Secant is the reciprocal of cosine. Well, let's do the same thing. I'm going to switch the hypotenuse and the adjacent, make it square root of 2 over 1, which is square root of 2. And then what's the reciprocal of 1? Yeah, 1 over 1 is still 1. Question? All right. John's good. How about the rest of us? Are we good? Okay. All right. Evaluate all 6 trig ratios of a 60-degree angle. To establish the ratios for a 30, 60, 90 triangle, we're going to start with an equilateral triangle with sides of length 2. Okay, so I'm starting with a 60, 60, 60 triangle, an equilateral. However, okay, so this is 60, and this is 60. What is this one up here if I drop this altitude? Or this height, there'll be 30 each, right? Because in an isosceles or equilateral, that height or altitude will also bisect that angle, and it will bisect this segment. So each of these will now be 1, for a total of 2 down there. Are we good with that? Okay, so what I'm going to do is I'm going to take this triangle right here, and I'm going to bring it out. So I have 60, 30, and 90 degrees. So I'm going to ignore that left-hand one. It's the same triangle pretty much, and I'm going to look at this one here. Okay, so this base right here was 1. This side is 2. What is this other leg? Or how do I find it?
Square 2, subtract 1 squared, and then square root it.
Because you're using what? Pythagorean theorem. Okay, so let's just call this side A. Okay, I don't know what it is. A squared plus B squared is C squared. That's our Pythagorean theorem that you'll probably know to the end of your days. Right? Like that one's just locked away in your brain, isn't it? B squared was 1 squared, and C squared is 2 squared. So A squared plus 1 equals 4. Well, that means that A squared is 3. And that means that A is what? Square root of 3. Okay, I'm not doing plus or minus because I'm talking about a length of a triangle here. So square root of 3. Everybody good with that? Okay, so the whole question is to find all 6 trig ratios of the 60-degree angle. So I'm focusing on this one down here. So when I say opposite, what length will I use? Square root of 3. When I say adjacent, I will use 1, and hypotenuse will be 2. All right, so let's set it up. Sine is what over what? Opposite over hypotenuse. Square root of 3 over 2. Is that already simplified? Yes. Radicals up top. That's what we consider to be simplest form, so we're good to go. Okay. Do you want to go ahead and do the reciprocal while we're on that one, or come back?
Yeah.
Okay. I kind of like to do those together. All right, so if I do the reciprocal, then that will be hypotenuse over opposite. Okay, now I have a radical in the denominator, so I'm going to rationalize. What fraction will I use? Square root of 3 over square root of 3. And that gives me 2 square roots of 3 over square root of 9, which is plain old 3. Any questions? How many of you can just rationalize that in your head without writing out that fraction? Hopefully we'll do enough that that'll kind of become second nature to some of you. Okay, so cosine is what over what? Adjacent over hypotenuse. So if I'm looking at the 60-degree angle, the adjacent side is 1, the hypotenuse is 2. That is simplified. Let's go ahead and do secant because it's the reciprocal here. So that's hypotenuse over adjacent, which is just 2. Stop me if you have a question. Okay, tangent is what over what? Opposite over adjacent. So looking at the 60-degree angle, opposite is square root of 3, adjacent is 1. Well, square root of 3 over 1 is just square root of 3. Okay, cotangent is the reciprocal, so it is adjacent over opposite. This one I do have to rationalize. Square root of 3 over square root of 3, multiply straight across, 1 times the square root of 3 over square root of 9, which is 3. Questions? Are we okay? Right. Let's see, how many do we have here? Okay, yeah, we're good, we're good. Okay, so memorizing those ratios, you might have already figured out that that's what I want you to do, will make your life, your classwork, your tests, your quizzes, your homework much easier if you know them. Okay, so super quick, what's the reciprocal of cosine? Secant. What's the reciprocal of cotangent? Tangent. What's the reciprocal of sine? Cosecant. Okay. Which ratio is adjacent over hypotenuse? Someone said it? Cosine? Adjacent over hypotenuse is cosine. What is opposite over adjacent? Tangent. What is sine? Opposite over hypotenuse. Okay, so as you work with these, try to really think them through so that they do become second nature to you. Okay, so these ratios here represent like generic triangles of the two that we just set up. Okay, so let's look back at the 45, 45, 90. See how the two legs were the same length? Well, these two angles are the same, therefore the opposite sides are the same. Those are just proportions of triangles there. So these will always be the same length, and this will always be square root of 2 times that length. So isn't that 1 square root of 2? Okay, so if this was 4, this would be 4. What would the hypotenuse be? 4 square root of 2. If this was 8, 8 square root of 2. Okay, so those are just the ratios of that similar triangle 45, 45, 90. That's what this represents. Whatever this leg is, this one is the same. And the hypotenuse is that leg times the square root of 2. Okay, so those are just the ratios that always hold true with those similar triangles, 45, 45, 90. Okay, let's look at the 30, 60, 90. What happened? Do you remember in a triangle, the shortest side is opposite the smallest angle? And the biggest side is opposite the biggest angle? So that's why the hypotenuse is always the biggest. It's opposite the biggest angle. The shortest side here is opposite the smallest angle. Square root of 3, how much is that? 1 point something, isn't it? The square root of 4 is 2, so this number falls between these two. Okay, so shortest side, smallest angle, opposite each other. Middle angle, middle side, opposite each other. Biggest angle, biggest side, opposite each other. Okay, so look up here, guys. Opposite 30 was 1. Hypotenuse was 2. Isn't that twice the measurement? Okay, but this was 1 square root of 3. Okay, so the ratio for any 30, 60, 90, opposite 30, whatever that is, we'll call it x. The hypotenuse will be twice that length, 2x. And the middle length side will be x times the square root of 3. Okay, and that ratio holds true for every 30, 60, 90 because they're all proportionate, because they're similar. Not like the overhead projector going forward and backward towards the screen, and they shrink and they dilate, but the proportion never changes. So those are the proportions of 30, 60, 90. Those are proportions of 45, 45, 90. Okay, so let's look at this next one. Let theta be an acute angle such that sine of theta equals 5/6. Evaluate all other trig functions of theta. Draw a picture that represents this triangle. Draw any right triangle on your paper. I'm interested how everybody's going to draw it. Any right triangle. Tyler, my friend, gets the originality award. He is the only person. Oh, John, I didn't see yours. Hold your paper up so I can see your triangle. He is the only person that drew his like that. Good job.
Thanks.
Good to be different. All right, so we all drew a right triangle. I'll go with the majority. Y'all did some version of this where the perpendicular sides were horizontal and vertical. Okay. Tyler, however, is more creative than we are, and he drew his rotated a little bit. Okay, where's theta? Theta is an acute angle. Where's your theta? Pick one. It doesn't matter. It's not the right angle, though, because that's not acute. So pick one of them. I'm going to pick this one. Tyler, yours will definitely be in a different place. You could also choose the one up here. We'll all end up with the same results. Okay, so I just chose one of the acute angles to be my theta. Now look at this. Sine of theta is 5/6. What does our ratio of sine represent? Opposite over hypotenuse. So basically, I'm giving you those lengths. So opposite theta is 5, and the hypotenuse is 6. So your opposite will go up here. There you go. And your hypotenuse is on the bottom. Perfect. Okay, so if it helps you, label. This is opposite. This is hypotenuse. And this will be my adjacent that I have to figure out what it is. Okay, so if it helps you, label them. Or just use O, A, and H. Okay, so how am I going to find my adjacent side? Pythagorean theorem. We're going to use it. You're going to be dreaming about Pythagorean theorem. Okay, I will call that A. So I'm going to say A squared plus B squared equals C squared. A squared plus 5 squared equals 6 squared. Y'all try to use your brain as much as you can. Oops, that's a plus. Not that I'm all about a calculator, because I am, but I think oftentimes we can do it faster in our head than our calculator. We just, our reflexes grab that machine when we don't actually need it. Subtract 25, what do you get? Square root it, what do you get? Square root of 11. Okay, so now we know the adjacent side. We had opposite, we had hypotenuse. Now I can find all the other trig functions. Okay, so I already knew sine. We don't have to do sine again. I am going to list it just because I'm going to go over next to it and find what? What's the reciprocal? But what's it called? Cosecant? Cosecant. 6/5, like John said. Okay, cosine is what over what? What, Max? Adjacent over hypotenuse. So our adjacent is square root of 11. Hypotenuse is 6. Good to go. What's the reciprocal of cosine? Secant. And the reciprocal is 6 over square root 11. I'm going to rationalize that. Multiply by square root 11 over square root 11, and I get what? A cool answer. 6 square roots of 11 over, well, square root 11 times square root of 11. 11. Technically square root of 121, but it doesn't even matter what that product is. If I'm multiplying two square roots, they just sort of, look, that's square root of 11 squared. Isn't that what I just did? Square and square root cancel each other out, and I get 11. Okay? Almost done. Tangent is what ratio? What over what? Opposite over adjacent. Opposite adjacent. Oop, gotta rationalize. Can you tell me what you would get? Over. Perfect. Okay, I'm going to have to squeeze cotangent down here. All right, so cotangent is the reciprocal of tangent. Don't flip this fraction, because then you have to rationalize again. Go back to the first fraction. If I take the reciprocal of that, then I'm done. Square root of 11 over 5. Question. Are we okay? All right, fun stuff. Okay, evaluate the following using the appropriate special triangle ratios. What am I talking about, special triangle ratios? These right here. Okay, these would probably be something else good to put on your formula sheet. Okay, so, hint, for the radian angles, you may want to convert to degrees first. Now, eventually, we're going to get to where we'll just know what pi over 6 is, but I know that's still very new to us. So we can do the conversion for now. Okay, so how much is pi over 6 in degrees? That's what we did yesterday. How would I find that? Use your formula. Which formula? All right, guys, come on. How do I convert pi over 6 to degrees? Look at that yellow sheet. You should have it on there. Multiply by 180 over pi. Love it. Pi over 6 times 180 over pi. Pi's cancel. Okay, we probably don't need a calculator. What is 180 divided by 6? What is 18 divided by 6? So we get 30. Okay, so this is asking us for cosine 30 degrees. Okay, we already set that triangle up. Go back one page. I want cosine of 30. I'm going to look at this triangle right here. Cosine of 30. Cosine is adjacent over hypotenuse. Okay, so let's go back and figure out what the adjacent to 30 is. Which number would I use for adjacent of 30? Yeah, this is opposite 30. This is adjacent. Hypotenuse is, so it'll be square root of 3 over 2. Okay, everybody see if that was a lot that went into that one little problem. Do you have a question? Okay, for those of you who like mental math tricks, if I'm converting that, how many degrees is equal to pi? Think about the fraction you've been using. How many degrees is equal to pi? 180. So if I want to convert that super quick, what's 180 divided by 6? 30. You got it. Converted. Pretty cool? All right, so let's try that on this one. Pi is the same as 180. So what's 180 divided by 4? 45. Look at that. We can already do some quick calculating. But if you're like, what the heck is she talking about? Then do your conversion. Okay, so cotangent 45. Okay, well, I have that triangle already. Flip the page. There's our 45, 45, 90 set up already. The ratio of cotangent is what over what? Well, give me adjacent, opposite, hypotenuse first. That's tangent. Adjacent over opposite. I'm just going to keep asking you because I keep wanting to get it drilled in your head so it's second nature. Cotangent is adjacent over opposite. Okay, I'm going to go to that 45, 45, 90 triangle. Here's a 45-degree angle. This is adjacent. This is opposite. So it's 1 over 1, which is 1. Okay. What if I told you there's some angle that I'm thinking of, and its sine is 1/2? What is the angle? I'm thinking of an angle. Its sine is 1/2. What is the angle? First of all, it's going to be one of these two triangles. Your answer is going to be found in these two triangles. Can you tell which one it would come from? Just based on the number 1/2?
I think the first one.
Do you?
Maybe.
But it's got a square root of 2 in it. It would be the bottom one. Which angle down there would have a sine of 1/2? 30. So I'm looking at 30 degrees. Opposite over hypotenuse is 1/2. So the angle that I was thinking of is 30 degrees. Are we okay with that? Okay, I'm thinking of a new angle. And its cosine is square root of 2 over 2. What is my angle? Your hint is square root of 2. Which triangle does it probably come from? Yeah, the one that has a square root of 2 in it. So which one has cosine square root of 2 over 2? We find cosine by looking at what over what? Adjacent over hypotenuse. Which angle has adjacent over hypotenuse square root of 2 over 2? 45. But wait a minute, it's 1 over square root of 2. But if you rationalize it, it becomes square root of 2 over 2. So my angle was 45 degrees. Yes. Yes. Do we need a quick bathroom break? Okay, let's go ahead and do that, and then we'll try to wrap these up. Yes. If we what? So like this one right here was not one of those. I have to give you enough information that you can find all three sides. And then we just